Thank you. My name is Josef Kostolny, and my team, last two presentations and me, we are from University of Žilina, Faculty of Human Science and Informatics. And this study is about the design and implementation of computer user fatigue monitoring techniques using eye tracking, camera, or ambient light sensor. The system would analyze user blinks and is needed at what time of day we are blinking, after what time in computer use, or under what lighting. The system will produce data based on which will be possible to identify patterns in fatigue changes and influencing factors. And this data could be in the future used by analyzing by biomedical experts. Okay. Theoretical basis in past years by COVID, every persons or every people on working on computer, and first syndrome or computer vision syndrome is include eye discomfort, fatigue, dry eye, blurry vision, and headache. Mechanism of eye fatigue is external muscles of eye and accommodation mechanism or ocular surface. And external factors we can consider in this study is room lighting. Important factors is lighting affecting on this eye fatigue. How to measure lighting and fatigue? Fatigue occurs with long-term computer and immoper lighting. It is manifested by a reduced frequency of blinking of the eyes when we use a computer. Ambient lighting, this level of light intensity can be sent using the ambient light sensor. For this solution, we are design two modules. First is a computer user capture module, and second is a computer use fatigue analysis module. First module consists from hardware, Raspberry Pi microcomputer, web camera, and ambient light sensor. This module produces a video recording of the computer user and CSV file of ambient light level values. And illumination values are in lux and is assigned to timestamps at the moment of capture. Second module, computer user fatigue analysis module, input these two parameters, video of computer user, which is recorded, and file with lighting values with timestamps. From this input, it will start analyzing of blinking moments of the computer user, and at the end, he connects these movements with a value of lighting and giving time. The output of blinking timestamps file with associated illumination value, and the end, likewise, the output is a graph of the average numbers of blinking in each minute, and give how during these analysis. Important aspects is ways of detecting eye fatigue. Eye detection in the image, or using facial landmarks detectors. Next is a determination of significant points of the face, and blink determination, A aspect ratio or blinking duration from approximately 100 to 400 milliseconds. Implementation, we use programming language Python and libraries SciPy, Immunits, Delib, and OpenCV. Physical board with the sensor is Raspberry Pi with ambient light sensor. On this slide is a demonstration of recording of video and blinking my my co-author, and data set of from ambient sensor with timestamp. This data with second module can analyze and creating these two graphs, which is average number of blinkings across the day and average lighting level during the recordings. This is two values which can analyze in the future, and this is a full data set which can be collected with this system, and on this graph is average number of blinkings per minute during the afternoon across 9 days. This is average 9 days afternoon work in the computer, and average or way of this count of blinking is down. In conclusion, aim of this work was design and implementing techniques for monitoring computer user fatigue. Introduce the technologies necessary for development is Raspberry Pi computer, microcomputer, and ambient light sensor, and design on an implementation of this software for collecting data and analyzing these computers blinking. And future works is calibration of phase detectors by elimination of tendency to rotate the face or another point of view capturing the face, connecting to a powerful remote server, storing layer which can give us a storing ledger of amounts of data, faster analysis, maybe real-time analysis, or machine learning computing on collected data. And finally, the determination of hidden correlation, which can decide between work of on the screen and maybe some point of view of some lighting. And these works, or one author is from Simon Helteners, and this solution is in progress for producing. Thank you for attention.
Thank you very much, because this is very typical for our work.
Yes.
My question is the following. I know there are other programs, other tools to minimize the risk of our eyes. They are based on more simple approach, time-oriented and so on, or preliminary analysis of what is this program, and after that support mode of good law. Your approach is more potentially more accurate, but more complex. And so my question is, maybe you can combine your approach and others.
Yes, this is a good idea, but this solution is about creating a system with microcomputer or maybe some low-cost device which can add the computer user, and in the future the system can inform the computer user it's time to change lighting level or some pause in the work because it's bad for eyes or something. This is a cooperation between these working on a hardware solution and software level with medical.
And the second question, maybe for future and some fantastic. What about application on embedded chip to understand what is really chip can do
Implants.
Maybe idea of Internet of friends.
Yes. Maybe in future.
Thank you.
if we find some respondents. Thank you.
That about putting the cloud or in a more cloud setup, did you find that it was too much of work for the Raspberry Pi to do the outline of the eyes?
No, but collecting of the data and creating video is making by Raspberry Pi, and this data is sent to another with in the future on the server, which can produce this analyze, because analyze video is very hard task for Raspberry Pi.
And it was not on the
No. Raspberry Analyze is not on Raspberry Pi. This most biggest.
possible to do it on
Yes,
the
yes,
Raspberry
yes.
Pi.
No, it is impossible in this way. But we have some solution. We if we don't record video and these liking steps use it for analyze, and in this moment capture image, and analyzing of image is possible making into the Raspberry. But video is a first step, and is a good solution, but it's not possible analyzing making on this Raspberry Pi. Yes.
So the frame rate with the standard 35 or 20%.
Yes, frame rate is standard on this solution. This is
I saw that this person was
yes.
like an officially standing at this thing, but normally we are
Yeah.
going crazy.
This is a future world with
So for the
tracking phase in another angle.
what about angle? Does it have to be like in the computer still, or could it be higher or the side?
In this work we using a front face camera, but if it's a change of angle and on screen is visible both eyes, is a solution for work.
And the segmentation of the eye, is it easy task in general or
Easy task because not only eyes, but is about finding eyes first time, and mouth for calibrate. This is a face, and another steps is counting these Vikings.
standard or it is pure standard?
Oh, standard.
And the second question, I have idea, maybe you can use additionally well-known technique, eye tracking. Did you analyze?
Yes, but eye tracking need special hardware.
It's,
Yes,
it
it's
is not-
Xbox
Yes, it is
Kinect.
not a lot of money.
Not money, but this solution is about making with basic camera or low cost camera, because this is a patented solution. I know if you can buy it from China, another replicas, but this solution is under Siemens containers
Yes,
work.
we have experience with eye tracking devices and software. And And come back, we will think about this accessibility. We will keep in touch.
Okay, next presentation